Right, so we are in 7.3. This is our last way of solving systems of equations. It's going to be by elimination. And so when we're looking at elimination, what we're trying to do is, first of all, let's think about what the word elimination means. It means to eliminate, correct. So we're going to eliminate or get rid of something. So using the elimination method, we're going to be getting rid of something. So first of all, we're going to make sure that the equations are lined up, preferably in the same form. And I use standard form. So I usually do ax plus by equals c. It doesn't have to be in that format, but that's kind of the standard. No pun intended. All right, so and then we're going to either add or subtract the equations and eliminate the variable with a common coefficient. Now, a coefficient is the number in front of a variable. So we're going to get rid of if it has a common coefficient, so like a 2 and a 2. However, I like to do adding regularly. So when I do my adding regularly, I like to have them have exact opposite. So common, but I want exact opposite coefficients. Because then I can just combine, like by adding, combine like terms. And then we're going to solve the equation for the remaining variable. At that point, you're going to have just one variable. We'll only have one variable. And then we're going to, after we solve that, we're going to substitute your answer into the either original equation. I don't care which one. And you're going to solve for the other variable. So we're still going to end up solving and solving and then writing as an ordered pair. XY. So here, let's try a few. So this first example, I'm looking at it and I want to point out that my y's are exact opposite of one another. Knowing that they're exact opposite of one another, that means that I can eliminate them when I combine like terms. So if I were to just combine like terms, these are going to go away, and I end up with negative 17x is equal to negative 34. And then I can just divide by negative 17. And to be quite honest with you, right here, we're already to step 3 when we're solving for that variable. So x is equal to 2. So once I have the x value, now I'm going to substitute it into one of the originals. I don't care which one. I'm going to go with the one with the least, or like the lowest numbers. So I'm going to use negative 9 times 2 minus 2y equals negative 4. That gives me negative 18 minus 2y equals negative 4. Oops, negative 4. Add 18 to both sides. Negative 2y is equal to 14. And divide by negative 2. So y is equal to negative 7. So my ordered pair is going to be 2, negative 7. Okay, and then let's try that second one. That second one, hopefully you see again that my, I've got a negative 2, but it's my x's this time. I'm just going to combine them. They're exact opposites, so they cancel out, and I'm left with negative 11y equals 11. I'm already to step 3, so I'm going to divide by negative 11. So y is equal to negative 1. plug it right back into one of the originals. So negative 2x minus 3 times negative 1 equals 1. So negative 2x plus 3 equals 1. Take away 3 from both sides. Negative 2x is equal to negative 2. So x is equal to 1. So my ordered pair is going to be 1, negative 1. So 1, negative 1. All right, so number 3. If I use number 3, my x's are going to cancel. And I'm going to end up with, so they go away. And I get 13y is equal to negative 13. Divide by 13y is equal to negative 1. Plug that right back in, and I'm going to use the, let's use the top one. Negative 8x plus 8 times negative 1 equals 16. So negative 8x minus 8 equals 16. Add 8 to both sides. Negative 8x is equal to 24. Divided by negative 8. X is equal to negative 3. And I can always check my answers because I can plug it in to the other one, the x and the y, and see if it works. All right, this next one. Now this next one, it's again my y's because these guys are the same, right? Exact opposites. So I end up with 2x is equal to negative 54 divided by 2. X is equal to negative 27. And then I'm going to plug that back in. And I'm going to say 8 times negative 27 minus 6y equals negative 24. Oops, I think I made a mistake. Let me erase. All right, there we go. I caught my error. This was supposed to be just an equal sign right here. So it's not a negative 54. It's going to be negative or positive 6. And then divide by 2. X is equal to 3. Thought that number was a little bit big for my practice there. So then I'm going to plug that right back in. I'm going to say 8 times 3 minus 6y equals negative 24. This is 24 minus 6y equals negative 24. So now I get negative 6y is equal to negative 48. Now divide by negative 6. Negative and negative makes a positive, and that gives me 8. So I end up with 3, 8. All right, and as we get further along here, what's the difference here? What is that difference here? Well, if I look at it, I still have coefficients that are the same. I've got a 4y and a 4y. However, they're the exact same. And so I need them to be opposite so I can just combine them. So yes, you could think about it as subtraction, but I'm going to go ahead and multiply by negative 1, which is the same as subtracting that whole quantity. And I'm going to get a negative 5x minus 4y equals negative 29. And then I'm going to do a quick cross that off and use the top one and the bottom one. So now I get negative 1x, those cancel, equals negative 5. Divide by negative 1, x equals positive 5. And I need to find the y value. So we're going to plug that right back in. And I'm going to say 4 times 5 plus 4y equals 24. This is 20 plus 4y equals 24. Take away 20. So 4y is equal to 4. Y is equal to 1. Same thing on number 6. Let's go ahead and try that. My x's are the exact same, so we're going to multiply it by a negative 1. So that's going to give me a 5x plus 10y equals positive 10. And then combine. So I end up with 4y equals 0. So y is equal to 0. We're going to take that value and plug it right back in. And when I do that, I get negative 5x minus 6 times 0 equals negative 10. Well, that cancels right away because 0 times anything is 0. So then divide by negative 5 on both sides. Y is equal to 2. Oops, x is equal to 2, not y. X is equal to 2. Number 7, very similar. 7 and 8 are the same-ish. So let's go ahead and do 7. Let's multiply the whole thing. If I want to get rid of my y's, by negative 1. So that makes it 5x minus 6y equals negative 22. Here I end up with negative 5x. The y's cancel. And that gives me negative 20. Divide by negative 5 on both, and I end up with x is equal to positive 4. Plug that in, and I'm going to say negative 10 times 4 plus 6y equals 2. That's negative 40 plus 6y equals 2. Add 40 to both sides. Now I get that 42 over there. So 6y equals 42. Divide by 6 on both sides. Y is equal to 7. Feel free to try them and then come back to me. You do not have to just go with me as fast as I'm going, and you can pause me at any time. All right, this next one, if I notice it, they're all exactly the same. So when I go ahead and I subtract that quantity, 9x minus 2y equals positive 17. Oops. That's going to end up giving me 0, 0 equals 0. Well, does 0 equal 0? Yes, so that's going to be a true statement. And what is a true statement? That means same line. So it's infinitely many solutions. So same line. And the next two, now we're at next 4 on this page. We're going to bump it up a little bit. So bump it up a notch. Here we are. We're going to bump it up a notch. So I look at my x's and I look at my y's, and I have nothing that actually cancels. Okay, so now I need to manipulate or adjust things ever so slightly. So we need to adjust. Need to adjust to make it work. Okay, we're going to adjust to make it work. So to do that, I'm going to look and say, well, I'm going to try to get rid of the x's, because all I have to do is one maneuver to get rid of the x's. If I multiply this whole thing by 3, I'm going to end, instead of just a negative to switch the signs, I want it to be opposite. So I want it to be I want this x down here to be a positive 3x. So I multiply everything by 3, I get a 3x plus 15y equals 72, because 3 times 24 is 72. Cross that off with a quick x off, and then I end up with negative 3x plus 3x is gone. Negative 2y plus 15y gives me 13y. And I get negative 7, excuse me, so it's going to be 65. And divide both sides by 13. And I end up with y equals 5. So number 9, if y equals 5, I can plug that right back in. And I'm going to solve for x. So you can still use the one that you like, the original down here. Absolutely. So x is equal to 5 times 5 equals, oops, 5 plus, that's a plus, equals 24. So x plus 25 equals 24. Take away 25 from both sides. X is equal to negative 1. Number 10, doing the same concept-wise, I'm looking at my x's and I'm looking at my y's. The idea is that you figure out what is the least common multiple that they can both work, that can make them both work. Now, ideally, I look for a coefficient of 1 so that I can just multiply one time, or I look for things that are multiples of the other. So in this case, I know that I can get rid of my x's. They're already opposite signs. If I multiply this top one by a 3, that's going to give me a negative 6. That's what I want. So I'm going to multiply it by a 3 and distribute. So I'm going to end up with negative 6x minus 9y equals, that's a 5, so it's going to be 15. I don't need to multiply by a negative because they're already opposite signs. Now I'm going to work with these two, and I end up with a 0, 0, 0 equals 18. Now pause a minute. The one just above that, I had 0 equals 0, and that was true. But 0 does not equal 18. This is false. And we know if we have a false statement, that means that they never touch. So never touch. So they have to be parallel. No solution. So no solution because they're parallel. And the last two on this page, let's look at that. They're in the same format already, but so I got my 9 and my 18, a 7 and a 3. Well, 7 and 3, the commonality there, I would have to actually go with a common multiple of 21 because those are both prime. However, over here, I can multiply the top one by 2. That will give me 18, but I want the opposite of that. I want negative 18. So we're going to multiply by negative 2. And so when I do that, I get negative 18x plus 14y equals positive 28. And then combine like terms with that bottom one. So 18x, take away 18x, they're gone. 3y plus 14y gives me 17y equals 28 and 6. Well, 28, 29, 30, 31, 32, 33, 34. Divide both sides by 17. So y is equal to 2. And I need to find the x value on that. So let's go ahead and plug in 2 for y. And I'm going to use that bottom one since it's just I can see it. 18x plus 3 times 2 equals 6. Well, that's 6. So 18x plus 6 equals 6. Take away 6 from both sides. 18x is equal to 0. Now, I still have an x. So it's not a false statement because I can still divide by 18, divide by 18. 0 divided by 18 is still 0. So x equals 0. So 0, 2 is my solution. It is an ordered pair point. And number 12, this one, I'm looking at 16, 8, 9, 6. I'm going to go with my x's, and I'm going to make them exact opposites. So I'm going to multiply this one by a negative 2 because I want opposite signs. So this is going to be negative 16x minus 12y equals 12. Then we're going to combine those, and I end up with the x's go away. I get negative 3y equals 27. Y equals negative 9. Because we divide by negative 3, divide by negative 3. Then I'm going to plug that right back in. And I'm going to use that bottom one, though, because I really do like that low numbers. So we're going to use that bottom piece. We're going to say 8x plus 6 times negative 9 equals negative 6. So 8x minus 54 equals negative 6. I'm going to add 54. And I get 8x is equal to Well, negative 6 and 54 gives me 48. So x is equal to 6. So 6, negative 9. That's kind of that is the process. Now it gets a little bit more in depth here on this next set because they're not going to be multiples of each other. So I'm going to pause this video and I'm going to make a new video for the second day of elimination.